Okay, let's make a start. Welcome everybody. This is the week 5 webinar, and the week is really to do with roofs and upper floors, but I thought for the sake of student comments that we might show you some of the wall takeoff that was given in week 4 as an exercise, so you might find that useful, and a bit later on we'll be showing you takeoff for roofs. Okay, so let's make a start. So for today's session, I'm going to go through the forum posts for you and feedback from yourselves. We'll be looking at measurement of walls. We'll be looking at the technology of roof construction. We'll have a brief look at section 16 of NRM2, and this is for the roof timbers. And we'll have a quick look at a takeoff for a trussed roof. And I don't know how far we're going to get today, but we'll try not to go too quickly. Okay, so the forum posts. Well, for last week, we're pleased to see that most of you are getting to grips with measurement. Now, measurement for those who are new to construction is quite a task to actually master. And as I've said before, it's like learning how to drive a car. There are so many things that you have to consider. Like driving a car, you've got the steering wheel, and you've got the pedals for the gears, and you've got to see where you're going. And all of these things have to be have to work together. And taking off quantities is a bit like that. So the first week, you were required, this is the first week rather, you were required to measure something using the dimension paper and the method of measurement, which is the RACS NRM2, or New Rules of Measurement 2. And this is for walls. So this was the week 4 exercise, and it was quite a biggie for you. And some of you have had a go and some of you hadn't, but I urge you to have a go at this exercise and post it on the forum so we can have a look at it for you. So week 3 exercise was for skirtings. Some of you are having difficulties, so this was simplified for you, and the revised answers were published. Also, the week 4 walls measurement exercise we were just talking about was also simplified. So what we did was we asked you possibly not to measure the porch walls, and that makes it a simpler exercise. I have to say, for any of you that are more than confident, please measure the porch. I'm not saying don't measure it. It's just that I'm just putting everybody onto the same page. So we did advise that for the exercise, you don't need to measure the porch. Remember, this isn't an exam. This is an exercise just to develop your skills. So we recognize for some that weeks 3 and 4 are the most time consuming, and we've had feedback from you to that extent. We recognize this, and you are learning new skills. So please be kind to yourselves and allow yourselves additional time to absorb the materials. This is quite normal. I mean, we've been running this module for about 6 years, and at this stage, most of the students that are new to the industry are experiencing the same pressures on time and the amount of information they have to absorb. But it comes eventually, and it comes quite quickly. So this is quite normal. And we are reinforcing the learning this week by also providing a tutorial for the walls measurement for you. So I think it's short, don't panic. This is quite normal. And in week, at the end of this week or week 6, you'll look back on it and say, it's all beginning to make sense. And this is the feedback we've had from previous years. So let's get into it. I'll stop actually. Have you got any questions you want to ask me before we launch into it?
There's nothing in the chat box, Malcolm. I'm not sure if anybody.
Malcolm, can I ask a question on the? I was just studying the assignment and questions, and I noticed something in the drawing that I may want your explanation on that.
Okay.
On the D, it's just I need a D on the window. It says open size 2,400 by 1,000 aluminum double glazed horizontal sliding window as specified in hardwood surround. The hardwood surround is what I wanted to find explanation to it. Does it mean you have the aluminum frame fixed into a hardwood surround in?
Right. What I've done is I've actually answered your question on the forum post already. So all you need, in short, all you need to do is to look at the overall opening. Don't consider hardwood frames or anything like that. It's easier than you think. Just look at the overall size of the opening, and that's your deduction. Okay.
Okay. Okay.
Right.
Thank you.
Okay. No problems. Right. If there are no burning issues, I'll just continue. So the first thing we do is the measurement has a procedure, and this will help you. So the first thing you do is you look at the drawings and understand the technology. And then you start your takeoff list. Now we've got a takeoff list and a question and answer sheet. And this was in week 3, and this is the templates. Please download them and use these templates. So start your takeoff list, which is your to-do list, and start your question and answer sheet. Because when you look at the drawings, you'll have your own questions. Create the dimension paper, so download that from the template. And as you proceed, ensure that you enter the dimensions and descriptions in the correct columns. It's very important, this. I know it sounds very picky, but if you don't, you won't gain marks. So I would put that as a thing to actually remember. And use NRM2 to help craft your descriptions, because NRM2, when you look at it, helps you actually to fill in the description of the items that you're measuring and provide plenty of space between your takeoff items. So that's a bit of procedure. And what I'll do is I'll repeat this throughout the whole of the weeks following, so that you get an idea that this is quite a regular procedure. Now we look at a drawing. Now this is the exercise that you were given last week, and you were asked to measure the external walls and internal walls. So the external walls are these. It's what we call the skins of what we call a hollow wall construction. In other words, there's an external skin, there's a cavity, and there's an internal skin of blockwork. So you've got brickwork on the outside, a cavity, and an internal skin. And this is a plan view. So it's almost a bird's eye view. You're looking down on the building. So this is what the walls look like. And for this exercise, we've asked you not to measure the porch. In other words, what we'll be measuring is that wall, or those walls rather, that hollow wall construction or cavity wall construction, that wall, and that wall. Okay, so we start to look at the drawing and understand the technology, which we've just done. And then you start looking at the dimensions, and it's probably not too clear there, but that's 6.6 meters. And that overall dimension is 8.6 meters. Okay, so that gives you the external dimensions of the external skin of the hollow walls. Right? So what we've got to do is we've got to find the girth, which means the distance all the way round of the external wall, and you take that on a center line, the girth of the cavity all the way round, and the girth of the blockwork all the way round. So that's what we'll be doing. I won't do the internal walls with you, and I won't do any deductions for the openings. You can do that. This is your exercise, so you need to work up the exercise. That's a slice through the building. And what we're understanding here is, and we're only measuring this, and the instructions for the exercise also, that we're only measuring the ground floor. In other words, we're measuring from there to there. So remember that dimension, 2.578. Okay. So here we go. So note we've included walls to up to the first floor level only, which means you measured the ground floor, and excluded the porch. So I put that in red for you. So the first thing we do is to generate a set of calculations, which is what we call waist calculations. So here we've got the length of the external wall, which is 8.6, and the width, which was 6.6. 8.6 and 6.6. Okay, so to get the total girth, it'll be 2 times 8.6 and 2 times 6.6, which is 2 times 8.6, which is that, and 2 times 6.6, which is that, and that. All fairly easy. So that's what we've got here. So that gives you 30.4 meters. Now, to get to the center line of the external skin of the brickwork, you take that total girth, which is 30.4, and you use the center line mensuration that you've learned in the earlier exercises. So you need to come to the center line of the external wall. Okay. And the way that's calculated is the 4 corners times twice times half of the width of the wall. Okay. So it's 4 times, twice times, half times the width of the wall. And that gives you 410 millimeters. And when we finish the webinar, go back to that and satisfy yourself that you understand that. So remember, we're coming inwards, so it's the girth basically is going to be less. It's like a running track. Those that are running on the outside are running further than those on the inside, and it's the same with walls. So we go to the center line. And I've explained earlier, the reason we do that is that we want to make these dimensions as accurate as possible. Because sometimes, say in Europe and the UK especially, you might have housing estates of over 1,000 houses. And a little difference like that can make a huge difference to the quantity of brickwork. So you can appreciate just how important it is. Remember, the girth is multiplied by the height to get the actual meter squared or superficial area. Okay, having done that, we then progress, and then now we want to find the center line of the cavity, which is there. And similar to what we did before, we start with the girth to the external face of the external brickwork, which is that. And we start reducing the brickwork thickness, which is 102.5. And then we add half of the cavity. The cavity was 100. So it gives us a total dimension of 152.5. So here, slightly different from above, we're not going to half of the actual brickwork width. We're going 4 times the 4 corners, times twice times, and the distance 152.5. And so we're deducting that from 30.4. Then we go for the center line of the blockwork, which is here. So we want the girth of the center line of the blockwork all the way, all the way around. Sorry, my mouse just slipped. So we start with the girth of the external wall at the external face, which was 30.4. And we start the mensuration for coming to the center line of the blockwork. So we've got the width of the brickwork, which is 102.5. We've got the width of the cavity, which we're now taking as the whole of the cavity. Remember above, we only took it as half of the cavity. This is the whole of the cavity. And then we're taking half of the blockwork width. And the blockwork was 100 millimeters, so we're taking 50. So we've got 252.5. So here we've got the 4 corners times twice times 252.5, which is 2.020 meters. And we take that off the 30.4, and then we get 28,380. I spoke about the ground floor height. So that's 2.375. Okay. So that's wall measurement. Now, that's as far as I'll go today. I don't want to go through the whole exercise because I want you to do that. And I want you to actually enter the dimensions on the dimension sheet, which is, you've got the 4 columns. So you've got the times in column, you've got the dimension column, you've got the squaring column, and then you've got the description column, which is that. And you can download this from the week 3 template information. And don't forget, when you're actually setting up a dimension sheet on the page 1, if you can put the drawings and the title of your dimensions. Okay, and you've got a sheet number. Now you can put the sheet number at the top or the bottom, it doesn't really matter. So what we've done there is we're doing waste calculations. I'll leave you to fill in the actual description columns. And this is what taking off is all about. It's a very detailed and quite a picky thing to do. But the reason for having this in this format and on specific paper is that when somebody else writes dimensions, you'll be able to follow them easily because you're using the same conventions, you're using the same procedures. Okay, well, I'll just stop there now. We've got time for a quick question.
Excellent, thank you, Malcolm. There's a
Okay.
couple in the chat box. One of them is relating to the assignment. Victoria's asking, what is the difference between the takeoff list to-do list and the items to be measured list included in the assignment brief?
They're the same thing. It's
Okay.
the items that you're actually going to measure.
Tatiana has just asked to confirm that there's no need to include the porch.
Not unless you want to, but we're trying to make things as simple as we can for you. Remember, this isn't an exam or anything like that. This is really an exercise to get you into starting measurement. It was something we appreciated by looking at the comments from students. Think, oh, there's far too much. We've got to do this, that, and the other. And I do understand, honestly, but we just tried to make it a bit simpler for you.
Now, Jamie has asked, what is the rationale for displaying the half in this way? Seems a bit confusing for the centre line of brickwork.
It's just when you're coming to the centre line of brickwork, you're using half of the width of the wall. I mean, you could have put the width of the wall times 0.5, if that makes it clearer, Jamie. But it is half the width. If you go back to the centre line example and have a look at the assignment 1 webinar I did last Friday, I had a little a couple of slides on centre lines there. You'll see what I mean by half of the width of the wall. I know it takes a bit of time to get your head around these things, but then you think, oh, I understand. it's what we call an aha moment, but it isn't all that difficult.
Right, sorry, Jamie's come back and he said he said, I understand the use of half. It is that there are not spaces either side of the half.
Okay, that's something that we can take on. We can take forward, Jamie, to make it clearer for you. So when you come to write your dimensions and you come to write your waist, make sure you've got spaces. So it's a comment that I take on board, Jamie, and I'll do that in the future. This is just to help you.
Okay, Jamie said, okay, thanks. Now,
that's no problem.
Olu has asked about calculating if there was curvature in the building. I don't know if you want to go into that, as there isn't in this instance, or if that's one for a forum.
Not at this time, Olu. But and I don't think we actually cover curved measurement works at this stage. So don't worry about it.
And then the last one at the moment is, are we required to put the NRM2 reference in the last column? Normally takeoff sheet TIDISI description, in your example, TIDISI description in NRM2. I think it's just trying to establish which is the correct way to follow.
I would, and there's a reason for that. Is it gets you used to using NRM2, and if you put the actual the code, that would be great, and that basically will allow you to add marks.
And then, oh, there's some more assignment questions coming in, Malcolm. I don't know if you want those at the moment or if you'd like me to hold on till the end.
Yes, please.
Okay, thank you.
Yes, thank you. Sorry, guys, but I'll see how much time we've got. So, so we're nearly halfway through the session. If you want to put those questions into the forum, I'm more than happy to answer them. I think I've cleared most of the questions up to midnight last night, so there shouldn't be too many and I'll look at those today.
There's just one from Tatiana, which is just relating to this. Sorry, I don't understand why it changed from half to just, and then we've got 4, 2 on the whole number formula.
Oh, yes, okay. It's because you're using the actual width of, say, the center line of the cavity. You're using the full width of the brickwork, and you're using half of the width of the cavity in that case to get you 152.5. And for the center line of the blockwork, you're using the full width of the brickwork, the full width of the cavity, and half of the blockwork. So you see, we are actually calculating a half, which is half of the cavity and then half of the blockwork. Okay, I hope that answers that. What I would do is I'll just give yourself some time to look through the centerline calculations, and so that it'll click. Okay. Right. Okay. So we're in week 5 now, which is roofs. So with roof measurement, the key elements are to understand the construction technology, and it's not too difficult, but roofs can be a little bit tricky when you're looking at hips and valleys, which I'll explain a bit later, and you need to interpret the drawings. So today's webinar will relate directly to the textbook, which is the Willis textbook, and the approach being to look more closely at how measurements for roof timbers are built up. So this is chapter 11. And I think it's the second worked example that we're actually using here. So let's go to the technology of roof construction. I've just put an arbitrary plan of a roof here. It's one of the ones in Willis. And what we've done is we put some pictures of roof trusses, just to give you an idea of what it might look like. So this is a view looking this way, if you can imagine that. And there's the hip, there's the hip, there's the ridge, and there's the ridge. And that's the eaves detail, which is there. And these are typical roofs which are built of individual timber members. Okay. Just let you take that in. And there's sloping timber running down the inside of the dogleg, which is a valley rafter. So that slopes down and that slopes down. Whereas here, that slopes down from there and from there, and the roof slopes down into the valley. So you see the difference. So that's a swept valley. And that's a hip. These are terms that we use. And the timber along the top, you can just about see that there. That's the ridge. Okay. Just to see what the roof looks like at the verge, which is here, we have something called a wall plate, which sits on the internal wall here. And we'll be measuring a wall plate. So have a quick look at that. That's the wall plate. And it's what the actual roof trusses the trusses actually sit on, and that's what they bear on. Okay, so the weight of the roof trusses is transferred through the wall plate, down through the wall. This is technology. These are roof joists which are running across, and those form the support for the ceiling for the first floor. So it's really quite simple. Just another view of what a hip looks like, which is that, and you can see the roof joists running across, and the rafters running down there. Those are rafters. Okay. Something we may not be dealing with, but it's where there's an overhang like that. You get a soffit, which would be that, and a fascia. The soffit fixed to the underside of the overhang, and the fascia fixes to the ends. It just tidies the roof up, and these are the end details. Okay. And those are the verge soffits there. Just another look at how the rafters are notched and fit onto the wall plate, which is there. And you see the wall plate is fixed to the inner skin of the cavity wall construction. So we've got the brickwork on the outside, that's the cavity, and that's the blockwork. And if you're that's a bird's eye view of what we're looking at. And the reason I put this slide in there, it just gives you the names of the various members. So we've got the common rafters, which are the sloped rafters, going up to the ridge board. And at the ends, where you've got the hip rafters, which is that and that, those in between are called jack rafters. That's a valley rafter, where you slope down to the valley there and down to there. And that's a hip rafter, where you slope away from the hip there and there. So I would, when you review this, I would come back to that. Anything that runs that way is purlin. I don't think you could see these, but underneath that would be the joists running this way and that way. Now, I put this slide in to describe the roof trusses. Now, previously, the rafters and the joists and any of the other bracing members have been individual pieces of timber. In other words, the timber basically is brought to site and it's cut to length, and then it's assembled on site. This is a different method. These are called roof trusses. And what a roof truss is, it's a pre-framed member like that, which is actually manufactured in a factory. And it's they use a gang nail process, which is there, 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 and there. And the whole unit comes to site like that. And there'll be several of them on a lorry. And they're actually offloaded and with a crane, they're lifted up to the building. Excuse me. And they're tied together with a tie piece, which is called a longitudinal brace, to stabilize it and stop the the trusses wobbling about. Because you can imagine if you set all those in place and then unhook the crane, it would fall over. So you actually put in tie timbers. And as with the individual members, the trusses actually bear on the wall plate, which is there and through there. And there's lateral bracing here. So looking towards your assignment, what you've got is, you've got and I'll put your assignment drawing here. You've got, these are two wings, a long and a short wing of what we call the main and the return. And we've got trusses here, which are just like these. So you can see how those are actually set in place. And there's a centering for these. And I think the ones we're using in the assignment, the information will give you what the centering is of the trusses. So you've got trusses all over 1, 2, 3, 4, 5, however many, to here. And you've got trusses there, 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 however many, and you'll calculate the number using the centering. So those are the trusses. Now you'll realize very quickly that you can't have trusses in this corner, and then you have to use the individual framed members. So it's a bit of a combination, Ruth, this. You've got both trusses and traditional cut timbers. And it'll take you a bit of time to work out both the valley, which should be there, the hip, which should be there, and the ridge, which should be there and there, and the timbers in between. Okay. Otherwise, it would be a very, if it was just truss rafters, that would probably take you 5 minutes to measure. There's no challenge in that. The challenge is actually working out these timbers here. So we'll take you back to a simple exercise from the Willis textbook. But before that, we'll take you to your rules of measurement, section 16. So what section 16 gives us, it gives us the timber members that we have to measure. So here's the primary structural timbers. Okay. So the first thing you do is to use NRM2, and you give the nominal size of the timber, which you get from the drawings. So it'll be a dimension of width and length, like 100 by 50 or whatever. And then in your description, as you build the description up in the description column, you then say what it is you're actually measuring. So the first thing we're going to measure will be wall plates, which is those, and that fits on top of the wall. So we'll do those first. Okay, and then we'll go to level 3 and basically identify any items that are relevant in level 3 and anything in the glossary. So the code that you'll be using would be 16.1.1. And if you're measuring wall plates, 0.3. And if there's any level 3s, that would be a 0.1 to 9, whichever was relevant. So I won't give you all of the answers. I'll just lead you into that so you can have a look at it. when you're measuring roof trusses, we've got engineered or prefabricated constructions. So the primary timbers are cut timbers and they'll be done individually. But here we've got prefabricated member, and there's the description of the roof truss. And what we'll do is we'll look at the description of the roof truss, which describes the roof truss all in one item in the description column. And I'll show you what that looks like. Okay. And any information that you've got here, which would be the length or manufacturer's references. Okay. And using NRM2 and the various sections is easy as that. In other words, you use these columns to build up your descriptions. Right. Let's have a look at an example of takeoff for a trussed roof. Now, take your time with this because you may not understand everything in this webinar. That's not really the idea. It's just we're looking forward to the week, so you haven't looked at any of the roof material yet. So just have a look at it and come back to it as you work through your study items for this week. So here they've got the Willis example. I think it was page 167, something like that, which you can look at in the textbook. So here we've got a plan view again, which is a bird's eye view, and we're now trying to understand what we're looking at. So here are the walls. Here's the cavity wall, external skin, cavity, internal skin and blockwork, as we saw before. And what we're told is that there are going to be roof trusses making up this roof. So the trusses will go across there, 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 and so on. And there'll be a ridge timber tying them together. And in this example, we've got bracings that we have to measure. These are the bracings. So what we're looking at is we're looking at a building which has got two gable ends. That's a gable wall there, and that's a gable wall there. And that's what it looks like if you look at the section. And that's what we mean by the gable wall with a triangular profile. And that would be vertical. The alternative to that would be it wouldn't be a gable, it would be at an angle. But this is a gable. So from this information, the trusses are Fink truss rafters, which is a name of a type of rafter, such as the one I showed you in the picture. And they're at 600 millimeter centers. Okay. It tells you something about the tiling and the battens and the roofing felt. There are binders which run the length of the building, which are timber binders, and they're giving you that dimension. And the preformed roof truss is made of 38 by 100 members. 38 by 100. The angle of the roof truss is 35 degrees, it's quite important. And the overhang is 240 millimeters, which is that. Okay, and the actual width of the wall is 100 block, 75 cavity, and 100 mil for the brickwork, or 277.5. Forgive me, the dimension's actually there. So we've got 100 mil internal wall, we've got a 75 cavity, and a 102.5 thick external wall. So you've always got to look at the drawings to try and find out where what the dimensions are. Here was me, I was running to an assumption there and I was wrong. So when I look at the dimension is actually here, 277.5. The actual span of the truss is 6.7 meters, and remember that, because we'll be using that later on. And that takes you to the internal face of the blockwork. So that's the 6.7 meters, and we're 9.640 meters in the length between the faces of the internal walls. So now we're getting an idea of what the roof is constructed from, how it's constructed. So how's the time? Oh, we've got a few more minutes, so let's first do the takeoff list. Now we're not going to do all of these. We're just going to look at the wall plate and the trusses today, probably the bracing as well. But that's your takeoff list or your to-do list. Okay. I would say when you're doing a takeoff list, when you actually start measuring on the drawings, you might find that looking at it closely, you've missed something. Well, just go back to your takeoff list and put it in. It's your list. So let's have a look at the wall plates. I'll go back to this drawing here. So the wall plates sit on the internal blockwork walls, which is one there and one there. Now, looking at NRM2, you'll find that there's a limitation of the length of timbers, which is 6 meters. And we know that there's over 9 meters, which is the length of the building. So what do we do there? Well, we have to lap to 150 millimeters the wall plate at about there. And we use a halving joint. But what that means to you is you have to add 150 millimeters length to the total length of the wall plate. And when you're measuring roofs, that's true for any of the roofing members. It doesn't apply to trusses, but if you had separate timber members, which were more than 6 meters, then you'd have to joint them, probably using a sophisticated joint and make an allowance in the length. But here we're keeping things simple and we're just dealing with wall plates. So here we'd have 6 meters plus an overlap, and that brings you to over the 9 meters, 9.6 or something. So we need to measure a wall plate along there. Sorry, the inside wall along there, and a wall plate on the other side, which is there. Because the trusses actually bear on the wall plate. So the trusses will be along here. like that. So the first thing we do is we look at the dimension, which was 9.64, which we saw earlier, and you need to add the joint, which is 150 millimeters, which brings you to 9.790. And remember, you've got a wall plate on either side, so it's twice times 9.79. Description from NRM2 is wall plates, which we identified. There's the size, and there's the specification, which are treated sawn softwood. Okay, so those are wall plates. This will be a waste calculation, which I must admit, I'm sorry I chopped that one off for you and put it in afterwards. Now we go to the trusses, and this is the waste calculation for the trusses. So remember, we've got 9.640 again, and I'll go back to the drawing to show you where that came from. 9.640, which is that distance there. You've got to allow a clearance from the actual end wall, and then you allow for half of the rafter size, because you're calculating centers. So that's 25 and 19 is 44, which would be twice times, so that's 88, because it's both ends. So you've got a dimension of 9.640 less 88 millimeters. So you've got 9.552. Now we're told the centers of the trusses is 600. So you divide that by 600, which gives you 16 trusses, okay, which is 16 gaps. So you then have to add one, which gives the total number of trusses, which is 17. Okay, and here we've got a calculation for the overhang. So we've got the eaves, which are 240, which we saw earlier, the wall, which was 277, which gives 517, less the fascia, which was 25 millimeters. That was the thickness of the fascia board, which gives you 492. So that's the total overhang, which we'll use later. So we've got 17 trusses from the waste calculation. We'll put that in the description. So the 17 goes in the timesing column, and the 17 slash, which means 17 times. Remember, that was 2 slash, which is 2 times. And that's the notation that we use. And under each dimension, we write the dimensions to 2 decimal points. This is very important, and it's underlined. If there was more than one dimension, we'd bracket them together with brackets. And that's also important to do if you've got more than one dimension. So here we've got 17 times 1. So the trusses, when you look at NRM2, the trusses are actually enumerated. Let's go back up to NRM2. So the roof trusses are enumerated, and that tells you there. Okay, the primary timber members, that are the cut timbers, are measured in meters for the length of the timbers. But trusses, because they're a composite item, are measured as number. So here's the description. So we've got truss rafters, and what are they made of? So you look at the specification, and NRM asks questions about this. So they're in sawn softwood. They're a Fink pattern here, comprising of 38 by 100 millimeter members. There's the 6.7 meter clear span. There's the overhang that we actually determined, both sides. There's the pitch. and they're jointed with 18 gauge galvanized steel plate connectors. So those are the gang nail connectors at each of the joints that make up the truss rafters. And the note on the right says that a dimension diagram could be useful. In other words, just do a simple diagram of the truss and the internal W bracing. So that's basically measuring trusses, which is dead easy. Probably the most tricky thing is calculating the centering, and there's a little bit of clearance when you come off each wall, which is 25 millimeters, and then you calculate half of the rafter. That's a little bit tricky. I spent some time understanding that. You can't have the trusses bang up against the wall, otherwise they would rot. The damp would come through the wall, so they need to stand off a bit. It's a bit of technology.
I think that's just answered the question, Malcolm, actually, because
Okay.
Cheekin has asked why the clearance of 25 millimeters and half the rafter 19 millimeters should be deducted.
Right, right. Okay, that's no probs. We're now going to measure some bracing, and I think this is probably about as much time as we've got, folks. So when you look at the Willis example, there's a little bit of trigonometry that you've got to do. In other words, the bracing, if I can go back to the drawing, the bracing is this. And what you need to do is you need to calculate the slope of the gable, which is here. And then with trigonometry, you then calculate that, because it's moving in two directions, not only across the page, but it's actually rising. A bit difficult to get your head around, but I'd have a quick look at that. So what we do is we take half of the span, which is 6.7, and we have the plate. So you've got a length on the plan. So the roof slope equals that distance, which is 3450, okay, divided by cos theta, which gives you 4.212. Then to actually get the slope length of the brace, you use Pythagoras. So it's 3.55 squared plus 4.212 squared equals 5.445. You might need to spend a little bit of time getting your head around that, but it's quite simple, really. I must admit, it's like going back to O-level maths, which we probably all did years and years ago. Okay, so we've got the roof members here, which are pitched, and they're 25 by 100 meter treated sawn softwood. So we've got twice 9.64 from the drawing, and then we've got the bracing, which is twice times 5.45. In other words, twice times is 4, 5.45, which is 5.45 rounded up, which is the bracing, and the 4 of the braces. 1, 2, 3, and 4. Okay. And we've got joist anchors. I'm afraid I'm going to have to stop there. We've run out of time. But what I will do is I'll put these slides up for you so you can have a look at them. And if you want to raise any questions during the week, I'm more than happy to answer your questions. But it'll help you when you come to actually do your week 5 roof exercise. All right. I'll just say if you've got any final questions before we go.
There was just one, which was regarding the, for the assignment, can we use Word to prepare the takeoff list and bill of quantities instead of the Excel sheet that's been provided in week 3?
Yes, of course you can. Yeah, because the Microsoft packages are actually work together. Yeah, but I just thought Excel would have been easy for you. Anyway, it's up to you. Oh, one thing I did want to mention, when we talked about in the study materials, the traditional dimension paper that you use in industry, which you will be using as a surveyor, has got 2 sets of 4 columns. What we do is, in our template, is just like this. In other words, it's given you 1 set of 4 columns. And the reason for that is it gives you more room to type, because we ask you to type the presentation. Previous years, we've asked students to use the traditional type, but there was a feedback that it made the typing very squashed. So we've taken advice from previous students, and we just ask you to do 1 set of 4 columns. And of course, you number each page. What we don't include is the 5th column. This is just for teaching. Your actual codes you can put in the description column, which is here. Okay. Right. Well, I'll wrap this up today, and I just hope that was useful for you. Right, I'll just stop the recording now, folks.